In this video, we are going to do a new machine learning project that is real-time facial recognition. So let me give you a brief overview that what is the output of the project. Then we will move to the roadmap that what we are going to do step by step. Okay, so the output of the project is like this. We will open our laptop's camera or webcam, and a colored box will surround our face and our name will be that in the box. So basically our laptop will recognize our face that who we are and what is our name. So let me just give you an example of that. Yeah, so I've just run my test sample and this is my face as you can see. So basically our camera is recognizing that what is my name and what is the name associated with that face. Okay, so this is a real-time face recognition which our system is doing. So let us see that how we will proceed to this project. So let me give you a roadmap of this that what we are going to do step by step. So basically first we are gonna feed our video that like we should open our camera and we should record that what face is in front of the camera, right? So I have made a separate snippet of video record. It is just to check that whether the camera is working or not. So by this code, we can check that our camera is working or not. Uh, don't be stressed out. I will explain each line of the code step by step. I am just explaining the roadmap right now. Okay. So this is about just checking this code just check that whether our camera is working or not. Okay. So this is a real test. And after this, okay, so after this, we are gonna collect our face data. So basically, in this snippet, uh, this the function of this code is like this. This code opens our camera and ask ourselves to write our name. Okay, so if I play this sample, so it is asking my name. So I will enter my name here, and after that, when I enter, then the camera will open and it will start recording my face. It will start memorizing my face and will put each and every data in an array. Okay, I will explain this entire thing step by step. I'm just like giving an overview right now. Okay, so this code recognizes this code basically collects our facial data and stores it in an array, and that array is used for recognition afterwards. So after collecting our facial data, we will run this code. This is basically facial recognition. Okay, so after collecting our data, we will store that data in another array and we will start another live streaming. I mean, we will start our camera again and it will match that this current face matches with the previous array and it maps down the name of the person with that figure. Okay. So basically first step is data collection of our faces, and then after that we will do face recognition. And we will use basically k-means algorithm in this and a classifier that is Haar Cascade classifier. Okay, so this is a brief overview of the project that what we are going to do. And now I'm going to explain you. Okay, so before diving into the project, let us first see that what is Haar Cascade classifier. Okay, after explaining this Haar Cascade classifier, I will explain you each and every line of the code that what we have done step by step. Okay. Okay, so what Haar Cascade classifier do is it is a collection of features like edge features, line features, and many or other features. So basic purpose of Haar Cascade classifier is it detects each and every feature of our face. Okay, so this is a box. It moves in every direction in the entire image, and it just collects the data that where is our eyes, where is our nose. I will show you the animation that how it works. Before that, you can just see on this website that how what is the basic documentation of Haar Cascade classifier. After this, I will show you the animation of this. Okay, so I've done the basic of this. So if I enter my image here, and the Haar Cascade classifier will basically classify that where is our eyes and where is our face located in that entire image. Okay, so as you can see that here is my face and these are my eyes. So this simple code which uses Haar Cascade classifier has just recognized that where are my eyes and where is my face in the entire image. Okay, so now let us see that this Haar cascade animation. Okay, so as you can see that this Haar cascade classifier is just moving in the entire image, and it is just classifying that where is our face and where are the other components of the face. So as you can see that the edge features, the line features and the other features of the Haar cascade classifier, just checking that where are the main features of our face. Okay, so it is traversing the whole image by increasing its size. So just see the animation. I've increased the size of the speed of the video to 5.5x so you can see clearly. Okay, so this is how Haar cascade classifier works. Okay, so I hope that you will get and you have got a basic idea of that how an Haar cascade classifier works. So in this video, in this project, we will be using that Haar cascade classifier to detect our facial components, and after detecting that, storing that face into an array, mapping that with the name of the person, and just recognizing that again by our k-means algorithm. Okay, so before that, before starting data collection, let us check that whether our camera is working or not. Okay, so by this code we will just check that whether our camera is working, yes or no. Okay, so let me just explain you this code. So this code is starting with like we will import CV2, like we are importing OpenCV library, and by this cap is equal to CV2. Let me just zoom in. Okay, so second line, that cap is CV2 dot video capture. It means that just open our webcam. Okay, so this line opens our webcam, and this loop just tells that if our webcam is reading our image, then just continue, and if it is false, then move out of the loop. Okay, so it shows like a video frame. Okay, so let me just open the camera. I'm playing this, and so as you can see that our camera has been opened, and after that this camera name, just the name of camera is frame, as okay, as you can as we have just seen before. And after this I have entered this logic that if I press Q as the key, if I press the key Q, then it breaks the camera and closes the window, and the camera will not be closed by the simple closing function. It will be only closed if you enter Q. Okay, so this is the logic which I have entered, and I will explain you the purpose of that, why I have entered this. Okay, and this is a key pressed. This line simply means that uh, if our currently pressed key matches with this key or not. That's it. And I will explain this the meaning of this line later in this project when we are doing data collection. Okay, I will explain the logic behind this, that why I have bitwise, why I have used bitwise and here with 0xff. Okay, so for right now you have to just understand that we have just opened our camera and just check that if return is equal to false, then we will just continue, and if our camera is reading, then we will just move forward and just show the camera that, and just check that whether the camera is open or not, and we'll just close that camera by pressing the key Q. Okay, and after that we will release our camera, cap.release. When we break out of the loop, then we'll just release our camera by this line. This means closing our camera, and by this it means that destroying all windows means disabling all the cookies that has been formed by opening the camera, and deleting all the data which has been captured in the back memory. Okay, so this is basically a video read. We are just checking that our camera is reading the video or not. Okay, so I hope that you have got a clear idea that what is this. Okay, So after that, we'll do facial data collection. We have covered this video read part, like we are just checking that how video is being read from your webcam of the laptop or computer, and how it is being processed and how the video is being stopping. So in today's video, we're gonna see that how the laptop camera or webcam is reading our face data and storing it in an array to like detect further. Okay, so this file face data consists that how our face data is being storing in the memory of computer, and we will process it later when we are doing face detection using KNN algorithm. Okay, so let us get started about it. So I will explain you line by line that what each line is doing. So let's get started. So first we import two libraries like OpenCV and NumPy library. OpenCV to like read the camera feed or open the camera, and NumPy has basic array operations and some more operations. Okay. So by this line we are just opening our webcam, and in this variable cap our webcam is being storing the data is being storing in this cap. Okay, so after that we are using, like in previous video I've shown you a Haar Cascade classifier that is classifying the facial components of the face. Okay, so we have just imported this Haar Cascade classifier in this variable, and like this is the location of Haar Cascade classifier. So before starting the project, just see here, it is in my D folder, D drive, and this folder. So this Haar Cascade classifier file, we will just download this from the internet. It is easily available on GitHub. So just download it, or I will give the link in the description. Okay, you have to store this Haar Cascade file in this directory only. So like, just wait a second. So in my D drive, I have a folder called Face Recognition Project, and in this folder, I have this file, Haar Cascade classifier file. Okay, this is Haar Cascade frontal face. So you have to just download this file only, and this is the mainly classifier we are going to use here. So we have just imported this classifier here in this variable. So let's move forward. This skip variable just means that I will explain you this later when we are just using the skip variable here. For now, just ignore it. And in this face data array, this is basically a list in which we will be storing each face data. Okay, so don't be confused. You will get a clear understanding later when we are proceeding towards it. And this dataset path is face dataset. So this means that the faces which we are storing has to be downloaded or has to be stored in the computer's memory. Okay, so like if I open my camera and store my face, so my computer has to download that face and store that file in a particular folder, right? So I have just created this folder here. So as you can see that in my D drive, I've created a folder face dataset by this line. Okay, and this face dataset contains all the files that has been read through my camera. So if I open it, I have just recorded my face and given my name to this, like anything, and this every data of my camera feed is stored in this data folder, in this folder. Okay, so let's move forward. So like when we open our camera, then we will enter our name there, as I just shown you in the previous video. When we open the camera, we enter our name, and after that video starts recording and our face is starting getting recognized and feeding the camera. Okay, so we are just giving it the input that when we open the camera, just enter our name, and in the console, this dialog box will appear where we have to enter our name. Don't worry, I will just play this video, like when I play this code, then you will see that what this line is actually doing here in the console. Okay. Okay, so let us just now play it once. So when we play this file, then in this console, you can see that here it is coming like enter your name, like enter the name of person. So when I write my name here like this and press enter, then the camera will open. Okay, So as of now, I'm just stopping this program. We'll do this later. Okay. So I've just shown you that how it is being appeared in the console. Okay, so let us move further. So now we are opening our camera and we will store our data feed now. Okay, so in a while loop, which is always true, we are just doing this code. So let me just explain you that what we are doing here. Okay, so this red comma frame is equal to cap read means that red is basically a boolean variable which just check that camera is open or not, and frame basically captures the is a variable where we are defining our camera. Okay, so and here we are just checking that if the camera is not open, then just continue and don't do this iteration. And this lines means that we are just converting our like initially we will be having a colorful image, like we all are colorful, right? So initially our images are RGB image, and in Python we just like RGB, like we let BGR instead of RGB every time. So in this line we are converting our RGB image to a grayscale image. Okay, and to convert that we use this type of syntax like cv2.cvt color and frame, which is storing our camera feed, and cv2.color bgr to gray. Bgr to gray means we are converting bgr like it means RGB. We are converting RGB to grayscale. Okay, so this is a syntax. So our gray, so initially we are having frame. In this frame we are having a colorful image, and now in this gray frame we will be having a grayscale image. Okay, so grayscale we have converted it to grayscale image because in KNN algorithm it is much easier to like understand a grayscale image and do the algorithm, like do the functionalities in grayscale image. It is much easier than a colorful image, and it doesn't affect the output. The output is much better in grayscale. Okay, so when we are processing grayscale. Okay, so let us move forward. And this line like faces is equal to face cascade dot detect multiscale. Okay, so I'm explaining the parameter that is used here. So this is a gray frame that is we just created here, and this is a scaling factor. This is the number of neighbors. Okay, so let me just give a comment here, like frame name, parameters of frame name, scaling factor, and number of neighbors that we define by k, and just we write number of neighbors. Okay, so number of neighbors is basically used in KNN algorithm. If you don't know the KNN algorithm for now, just skip this line. I will explain the each and every functionality of scaling factor k and the whole functionality of this line later when I will be explaining the KNN algorithm, because you will get a clear understanding then. Okay, so just let me give you a quick overview that what is the scaling factor. So initially, if our image size, if we scale down our image to 1, then if we are doing 1.3, then simply means that we are just shrinking our image to 30%. Don't worry, I will just explain you this step later when we are doing K-NN algorithm. So for now, let us move further. So in this line, we are just checking that if faces length equal to 0, like if this um, if this face is equal to 0, then just continue. We don't have any face here. Okay, so as of now, just understand that this line, like this function just returns you the coordinates of the face captured. Like if I open my camera and the camera will capture my face, then this function will return the coordinates of my face, like top left, top right, bottom left, bottom right. Okay, so all the coordinates will be returned by this function to this faces variable. Okay, so this lines, this function is only doing this. This is just telling the coordinates of faces to us. Okay. Okay, so let me just explain you that what actually this function is returning us and what type of coordinates are they. Okay, so just let me open my notepad. Okay, so this function, like this function, so let me just select brush here. Okay. Okay, so this function like face cascade dot detect multiscale, this variable faces just means that this faces is a list, and this list is storing the coordinates of the face. So if I draw here, like if I draw faces, like like if this is a person here, and like if this is person one, like person one, and if this is a person two. Okay, so these both are faces. Okay, so these are the top coordinates, like xy are the top coordinates of the faces, and this is the width, this is the height. Okay, so a box, it returns like this. Detect multiscale returns a block to you, like it returns a box in which we have the top left, and we have the top left coordinates of xy, and the height is h, and the width is w. Okay, so this function just returns x. This function returns x, y, w, and z. Sorry, w and h. X, y, w, and h. Okay, so these are the coordinates, and by this w and h, we can just calculate that what can be these coordinates. Like this can be like x plus h and y plus w, right? Like you can just calculate it by adding w and h in x and y. So we can get these and these coordinates also. So this function is just returning as the coordinates so that we can just make a box into the face around the face. Okay, that's it about this. Let us move forward. Okay, so now let us see that the further code. So this line like faces is sorted faces key lambda x2 into x3. So what is it is doing? So it is just arranging your faces. Like if you have multiple faces in the video feed, like if I show my face, my sister's face, my brother's face, my parents' face, my friend's face, so multiple number of faces will come, right? And we have to sort that faces in increasing or decreasing order as per our need. Okay, so what we are doing here is we are passing a function named sorted, and we are just using a lambda function. Okay, so in this line mean that we are passing our faces list here. Like in this faces list, we have x, y, h, and w coordinates numbers. Okay, and we pass this list here, and we are just calculating. So this means that okay, so like faces list is like if you have faces, then faces contains a list of x, y, w, and h. Okay, so it is 0 index, this is 1 index, this is 2 index, this is 3 index. Okay, so the area of image is what? Area of any image is width into height. Okay, width into height, and width into height basically here is faces to into faces 3. Okay, this is width into height, and this is basically area. And the image which have larger area will obviously come first if we are sorting it in a decreasing order, and if the area is less, then it will come first in the sorted order if we are sorting it in a ascending order, right? So this, so in this here, so lambda x is just representing our faces, and we are just using lambda function here. If you don't know, like what is lambda function, so let like just get a quick overview by seeing the documentations. Okay, so x is representing this faces, and x2 into x3 basically is area of image, area of the face, or area of the box which has been made. Okay, and reverse is equal to true means which we are just arranging this in a descending order, like we are sorting it in a descending order, right? So and these, like if we are having faces like this, first face is this, second phase is this, third phase is like small phase, then big phase, then small phase. Then these all phases will be sorted in a descending order. Like first will come big, then small, then small, then small. Okay. So in this way we sort our phases, and every data will be stored in this variable. Okay. So I hope that you get a clear understanding of what we are actually doing here. And now just forget this line as of now. So now we will just iterate to the every faces, and we will just store every face in our data. So now we are just iterating in our faces array. So let us see that we are starting a for loop here, and for loop is going till end. Okay, and this x, y, w, h is are the coordinates of the face. So face and faces means that it is like this is phase one, this is phase two, this is phase three, this is phase four. Like these are the phases, and the coordinates of each and every phase will come in this x, y, w, and h variables. Okay, as we iterate over every phases, then the coordinates of every phase will come in x, y, w, and h. Okay, and this offset simply means that we are providing a padding. So if you have done HTML before, you might know that what is padding, what is margin. So padding is basically a so if we are having our face here, this is our face, then this gap is basically padding. Okay, so this gap is padding. Sorry for the handwriting. Actually, pen is quite bold here. Okay, so if we are having a face here, like, and this is covered in a box, then this box is having a padding of 5. Okay, so this length is basically 5 padding. Okay, so we have just given the padding of 5 to like show a clear user interface. Okay, so as before, we are just having this box as an outer box, which we are having the coordinates x, y, and everything. So now here we are just extracting the face section. So this line is basically extracting the section of a face. So it is subtracting the offset. So basically, it is subtracting the padding, and it is just calculating a particular section of a face. Initially, there was padding, and now we are just calculating the particular section of the face. Okay, and after that, like you will see, you can understand this easily. Like we are just subtracting offset from top and bottom, and subtracting from left and right. Okay, we are just subtracting our padding and just getting the section of face by this line. Okay, just go through it once. And by this face selection, we are just resizing our face to 100 cross 100 image. Okay, so I hope that you understand it. And now this skip. So this skip just means that when we start recording our face, then after every second, our skip after every second or after every iteration, this skip will increment. Okay, like we have recorded one first phase, second phase, third phase, like a particular uh, time frame of the phase is being recorded by this skip variable. Okay, so after every 10th phase, like when I started recording my phase, so I recorded at first second, second second, third second, fourth second. I'm recording my face at every second. Okay, so when I read the 10th second of camera, I will just do a skip operation. Okay, and after every 10th phase, I will be recording this 10th phase into my array. Okay, I'll be recording each 10th iterated phase in my array so that I don't have many phases in my array, and I have a good feed rate and a good video feed to like recognize later. So as you can see that like after each 10th iteration, I'm just appending my face into the face data and just printing the length of face. That's it. Like understanding this line simply means that we are just creating a rectangular box towards our frame. Like frame is basically a section of frame, a section of face which we are having, and these are the coordinates like top left coordinates, and these are the bottom right coordinates. We pass these parameters and the color of the box which we have to display. Okay, so this is RGB, red, green, and blue. So basically, we have given green to its full number and red and blue to 00. So basically, a green color box will appear around our face. Okay, so like let me show you that. So when I will open my camera, so what will happen? Like a camera will open like this. it will be a frame and my face will be here, like I will be standing or sitting here, and a green color box will appear around my face, like around a section of face, a green color box will appear. Okay, and by this, like this is basically RGB. I have given 0 to R, 0 to blue, and 255 to green. 255 is the maximum number, that's why a green color box will appear. If I give like 255 zero zero, then a red color box will appear around my face. A red color box will appear. So this line is simply creating a rectangular box which will appear around this frame. Frame is basically this frame. Okay, so and by this will just show the frame, like it is understandable. And this is like that. If we have if a webcam is open, then if we press a key q, if we press q, then the webcam will just switch off. Like I will explain the function of this later, so let us move forward about this as of now. And so now after when we have stored our faces, then after that we will be having a list of faces. Like we are having a list of faces in which faces data are stored. Okay, so now to implement a k-means algorithm here, we have to implement basically knn algorithm here. So it implements only on numpy array. So a numpy array works best in some scenarios, and the computation power is pretty much high than list. Okay, so we will convert our list. So base data is basically list now. We will convert this list to a numpy array by this function, by np.array and a face data here. We are basically converting our face. This is a list here as of now. We are converting this to a numpy array. Okay, so to have a faster computation and to better fit in a knn algorithm. After converting it to a numpy array, we will just reshape it. Okay, so reshaping is a basic concept. You will know it, and if you don't know like what is reshaping, I would say that just look at the documentation, like what it is doing. And after this reshaping, we are just printing our face, not shape, face data shape. Like what is the face shape? Like what is the shape of the face as of now? And after that, we are just saving our data in our folder which we have just made. Like just let me explain you this. So this dataset path is basically the D drive path which I have just stated earlier. So basically this is the dataset path, and now we are just storing our like current data into this folder. Okay, so to store our data in this folder, what we are doing is like we are just saving our current data path, file name, and face data. Okay, so file name is basically this. When we are entering our name, the name is storing in this file name. Okay, so now just see that what we have done. We have saved our data set plus file name and face data. And so if we print this, it will be like data set. Like let me just show you, if we print this, what will happen here. So now when we print it, like it will come like this. If the folder name is my data, if data is my folder name, then and my file name is, if I write my name like Arpit, and extension is basically .npy because we store in this. So this will be our location or source where we are storing our current data. Okay, so this arpit.npy will contain all the faces, all the my face data which is being stored in the camera feed, and we will use this data to recognize and pass this data in our knn algorithm, which we will make later. Okay, and now by this is just means that we are releasing our camera which we have just opened in our webcam, and this lines is just destroying all the windows which have been created by the camera, like basically the frames which have been created here. Okay, so this is the basically everything about face data reading and data collection. So now we will just see that how we can recognize our data by using a knn algorithm. So this is basically the code of the face recognition, and here I've implemented a knn algorithm, that what the algorithm is doing. Okay, so I will explain line by line that what every line of function is doing. I'll explain everything. And if you have any confusion, like if you don't want to make KNN algorithm from scratch, like here in this video, I've made this algorithm from scratch. You can also use inbuilt library, like KNN inbuilt library comes. It just works in simple one line, and here I've used like many lines here to implement it from scratch. Okay, so you can use like direct library function also, and you can also like implement it from scratch. Okay, so don't worry about that. We will just discuss everything here. Okay, so before starting like face recognition, let me just give you a quick overview that what is KNN algorithm doing. Okay, so now let us see this. Okay, so now let me give you an example of like what is KNN in a very simplest way, and I will show you that how our KNNs can be implemented in this project also. Okay, so let us see that. So if we are having suppose I'll give you a small example before, like we are having a class one here. So let me just okay. So it is my class one, and okay, and I am just let me change my color, and this is my class two, and in between this class one and class two, I have a person here. Like suppose this is me. Now I have to like go to class 1 or class 2, and we have to find that this one belong to which class, like this one belongs to this class or this class. We don't know as of now. So what we do is we will find distance of current point with all the points and find the nearest point to this green point. Okay, we find distance to every point and we'll check that what is the average nearest distance we have. So suppose if so what we do is we find distance of this green person to every person of the class, and we find the top k persons. Like suppose we find distance to every person in the class, and after that finding we just categorize the top 5%. Like if we write k is equal to 5, then these 5 people are the nearest people to this. Like if k is equal to 5, then this 3 people, like this 3 people of class 1 and these 2 people of class 2 are the nearest people to this green. Okay, so k is equal to 5 simply means that these 5 people are the nearest k people to this green color, this green person. Okay, now there are 3 persons of class 1 and 2 persons of class 2. This simply means that the we will just check that at which class we have the most number of nearest neighbors. Okay, so this class 1 has the most number of nearest neighbors to this green person. Okay, so as class 1 has 3 neighbors, class 2 has 2 nearest neighbors. So obviously we will categorize our this green person to class 1 because these have more nearest neighbors as compared to class 2. Okay, so here class 1 wins. So basically this point belongs to class 1. It is a basic overview like what is KNN, and I will explain this in this further video like by giving more detailed examples. I explain you the complete like how to take facial data and store into a NumPy array, and also showing you the basic quick overview that what is KNN algorithm. And in today's video we're going to see that how KNN algorithm can be implemented here and why should be implemented here. Okay, so like in this project we are like recognizing our face with this KNN algorithm, but this is not the only way. There are many other algorithms like uh, convolution neural networks and like many other things by which we can like recognize our face. So this is one of the method KNN by which we recognize. So let me give you example that how KNN can be implemented here. So just see this. So suppose that it is my graph, and suppose I have stored the data of 5 people, like 4 people. I have recorded the data of 4 people, 4 of my friends, and one is me, and other three are my friends. Okay, and total is I have four people. Okay, one is me and three are friends. So just let's see that. Suppose this is me. Uh, these are my face records. Like I have just told you that I am recording my faces after every 10th iteration in and it will depend like when the number of minutes or seconds or hours I will open my camera, it my face will be get recorded, and due to that I will be having number of faces. Like if I open my camera for 10 minutes, then I will be having a lot of faces recorded. If I open my camera for 1 minute, then I will be having only six faces recorded, because the my faces are recording after every 10 seconds. Okay, it is just a overview example. So suppose I am having like my six faces, and every friend of mine is having six faces story. Okay, so this is person one, and these are the faces of person one. And just let me change the color. This is me, and suppose this is my friend face. Okay, this is my friend's face, and like friend one, and this is me, and suppose I'm having one more friend's face stored. Okay, so this is my friend's three face, like a second friend face, and these are the faces of my friend three. Okay, and now I am just like these are stored in my data. These all faces are stored in my data, and now I open my camera feed to recognize and use KNN algorithm now. So suppose I open my camera, and I open up my camera, like my camera face has been opened, and a random person comes in the camera, like it is none of us. So it will not match with any of them, and it will just simply cannot recognize. Okay, so if I open my camera and I show my face to it, like I show my face to it, and it will recognize my face as like this. So how it is happening? So if I open my camera, my face will come here. Like this is my camera and my face will come here. So now my face will calculate the distance from every facial data. Okay, so I have just said you that I have used Haar Cascade Classifier. So by Haar Cascade Classifier, I am just calculating my difference between faces. Okay, so I will calculate the difference of my face with every other face is stored. Okay, with every other face is stored, I will calculate the difference between my face and other faces. Okay, like every faces. Okay, and I will just calculate, like if I take k as 3, then I will just get the three nearest neighbors, and obviously I will be having the least facial difference with me only. If I am appearing in the front of the camera, then I will be having the least facial difference with me only. Okay, so by this algorithm we can just state that I am having like this face means this is me, and if it recognizes that this face means Arpit, like my name is Arpit, so it will just recognize it and show my name on the box. Like don't be confused, I will explain everything step by step after like moving into the code. So let us get started about that. Okay, so let us get further, like explaining the what is gonna done here. So in this face recognition file, what we have done is we have just imported our NumPy library, OpenCV and OS library here. Okay, so this is the code of KNN algorithm, and if you don't know like mathematics of KNN algorithm, then I prefer you that like just read the documentation or just read any video, just see any video and or see any code and just try to implement it by your own. Okay, if you try to implement it by own, you will get a clear understanding that what this is doing in actual. I have explained to you like what are the logics which have been done, and these logics are simply coded here. Okay, like sorting on the basis of this and frequency of each level, finding the max frequency. I've just explained you everything about this. You have to just understand like what code is doing. So and this is basically a distance. Like this point distance from this is basically Euclidean distance, which is uh, x1 minus x2 whole square plus y1 minus y2 whole square. So this is basically Euclidean distance. You might know this as everyone has studied this in school. So here the Euclidean distance is being calculated, and here is the basic logic of KNN. So I like give the task to you to find that what this KNN actually doing. So I have explained the logic. Just go through it once and understand that which and what is this KNN code is doing. If you don't understand, just write in the comment box. Like I will explain everything about that and make another video of KNN if you don't understand. But this is very logical thing. I've explained the logic. Just go through this code once and understand that what it is doing. Okay, this is quite simple. So so now let's move to our main logic, that how to recognize that using our KNN algorithm. So I've just changed my IDE because previously I was having Spider IDE that comes from Anaconda, and now I'm having IDE of PyCharm. So it doesn't affect our code, and so let's start it. So like in the previous video, we have seen that like all the things like face data collection, video camera on, like how to do that, face recognition, okay, all of that. And now like we have to do like the last practical part of it, like we have to recognize our face after loading the data of the faces, right? Like I will open my webcam and I will upload my data. Like I will start the webcam and my camera feed will constantly and consecutively load my data, okay? And after that, like my facial data will be stored in a numpy array, and in prediction I will use that numpy array for in my KNN algorithm to predict my new face, okay? So basic overview that like in your family, just record the faces of 4 or 5 people, and after that in the data collection record that, and while the data recognition, just one person come in the camera or multiple persons, and a label will be come and around your face and a box will come. I will show you that later, okay? So till then, just see here. So this is our face recognition code, okay? So like we have done this face data collection and like everything we have done till in the earlier classes. And this is a Haar Cascade classifier which we have used for detecting the facial components. And now like let us see our face recognition file. So basically like we have like now like we have discussed KNN algorithm in the earlier class, like how our face is detected in the bunch of many faces, okay? So like this is my KNN algorithm. I have not used the library function, rather than I have coded it from scratch, okay? Like I will show you later. Like I've also told you to study this KNN code by yourself. So basically it is nothing, just calculating the Euclidean distance and just calculating that which face is the nearest face to the point of convergence, like to our new face, how many previous faces are near to us, okay? So like that thing is done here. Like I have also given comments and just you can read that, okay? And like I will share this code, I will share the GitHub repository so that you can read the code and understand it and run it in your computer, okay? And as of now, let me just unhide the scale code. Okay, so now let me just unhide it. Okay, so I have just minimized my KNN code. So let us see now like what further things I've done in this part. So like initially, like while I have to recognize my face, so before that, like basic steps has to be done as we have done in previous classes. Like okay, so like we have to first open the camera. Like when we open the camera, then only we can like put our face in front of it, right? So first we open our camera by cv2.video capture 0. By this we are opening our webcam. Like there is an OpenCV function video capture, and by this we open our webcam, and like with C, and I have stored my webcam in this cap variable. So cap will contain my webcam, okay, my video feed basically. And after that, like I have called my classifier, that is Haar Cascade Classifier, and the function to call our classifier is Cascade Classifier. Okay, and there are multiple classifier like Haar Cascade frontal face classifier is only used for like detecting over faces. And there are multiple classifiers like which are used for detection the number plate of the car, or a person is the gender of a person, or many things. So there are like a lot of classifiers which have already been made. So we have used Hardcastle classifier to classify a particular part of the faces. Okay, and after that just see this data set path. So like in previous video we have seen that whenever we are capturing our face, then we are storing that face in a particular data file. Okay, so just see here face data collection. Here we have stored our face. I think here, just see here, like we have stored our face in this dataset path. Okay, and this dataset path is basically this folder. Now like when I show you this folder, so just see here, I think this is a folder. Okay, just see this. Okay, so this is a folder that is like this is my folder basically, which contains my all the files, Python files, and this is my face dataset folder, in which all the faces, like whatever the name I've given in the data collection is being written here in the .npy format. So if I open this like face data, then you can see that when I was printing it, then I was printing in such a way like dot format dataset path plus file name plus .npy. Okay, so you can see that like it is my dataset path is face data, and dataset name and file name is this like uh, this is my name, and this Arpit the media is a file name, and .npy is the extension. Okay, so like this is my stored data, and now I have to use this data. So like in face recognition, uh, I will be using my this facial data for the recognition part. Okay, and this is our normal arrays by which we are just calculating our facial data, like where we are storing our data, and label are the name of the data, like what is the label like currently, and class ID, like I have made two new variables here, class ID and names. So class ID will be basically labels for every given file. Okay, and names are like we are mapping a particular name with a particular data file. Okay, and now let us see like how to do data preparation. Okay, so like just see this line, just see this loop for fx in os.list directory dataset path. So basically os is a another library in Python which is used to for interaction with our operating system. OS basically means operating system. Okay, so here you can see that like I have also imported this OS file, OS library basically, and now I'm using that. So by this os.list dir, it means list directory and dataset path. So this line is basically looping in my this folder. Okay, this is my folder face dataset, and here my like this loop is like this line is iterating over this folder. Okay, so every file, like every file which is present here will be in the fx, like we will be iterating over every file, and like in this line fx dot with end with, it is just finding that which file ends with this extension .npy. So basically if I made some new file here, like if I made a new folder here, suppose new folder, and suppose I make a Word doc here. Okay, so like I made a new folder and a Word doc. So basically if these folders are present in my file, so I have to just find the .npy files. Okay, so with if fx dot ends with .npy, I am finding just only .npy files where my data are stored. Okay, where the different faces data are stored, I'm just finding those files. Okay, and like just see names names bracket class id is equal to fx colon -4. So I hope that you remember the slicing operator we have discussed in previous class also, like what is the slicing operator. So basically Just see this. We are taking all the characters except the last four. Okay. So last four are basically this dot npy are the last four indices, right? And everything before dot npy is our name. So basically this names class id contains our name basically. Okay. And here we are just loading our data and appending this particular name and data item in my face data array. Okay. So face data array is this. So we are just appending every data in this face data array. Okay. And now just see that now we are making a particular target variable. Like suppose we have five persons. Person number 1, 2, 3, 4, 5, and these 5 persons are the family members. Okay. And now like we have to make a particular array, a particular scaled down array with that 5%. Okay. So just see that like we have to make different target arrays for that. So initially my class ID is 0. So like just see this line. So basically like we have target variables for different faces. Like we have stored our facial data and now we are just simplifying that data into target variables. Okay. So target are nothing, just a simple array. Okay. So basically what we are doing is like initially like we are having classes like initial class is 0 and after that like will be incrementing our class ID with every iteration. So a particular class ID is associated with every face data. Okay. Initially my class ID is 0 and now just see this. Like I have got my data item and I'm just taking the shape of the data item, like the length of my data items. Data items are basically the number of times our face has been stored. Okay. So like I'm just calculating the length of the data item and like converting that into an array of ones. So I'll be forming an array of ones with the length of the data item. Okay. The size will be length of the data item and I am multiplying it by class ID. So my class ID is 0. So when 0 is multiplied with the np.ones, it will become an array of zeros. Okay. So this will be my target number 1. After that, like I will increase my class ID, I will increment it, I'll store that target in the labels array and I will just move to the next iteration. After that, I will go to my second phase. Okay. And what I will do is like I will get in another data item. I will calculate the size of the data item because I'm having a different person now. And I will make a array of ones and the size of that array will be data item size. Okay. And I will multiply that by class ID. So whenever an array of ones is multiplied with class ID, which is 1, so it will become the same array again. So that will be my target number 2. And similarly, when class ID are being incremented, so basically like when class ID is equal to 2, when 2 is multiplied by array of ones, then it will become an array of 2. Okay, the basic difference is that the size of these all the target arrays are different. Okay, based on the particular faces, the size of arrays are different and the number of the arrays are different. Okay, so that's how like we are just modifying the facial data into target variables and storing all the data in this labels. So labels is also an array. We are just storing all the different face data in labels. Now we are just printing that data, like what are the face data we have, what are the face labels we have, all of that simple stuff, and just combining that into np.concatenate face data and face labels. So face data is the face data and face labels are the labels of the faces associated with that. Okay, and now just see that like we have printed that stuff and now like this is my font, this line doesn't care as of now, and now just see that like this line. Okay, so now just see that like so now like we have like stored our facial data, like we have extracted our data from the data set and we have just stored that data. Okay, now like we have to implement our we have to call our knn function and we have to make a box around our face. So what will happen is that when you store your face data, okay, and like one part is storing our face data in face data.py file, and now like when we are recognizing it, like open your camera, like play this file, your camera will be open, and when you will show your face in front of the camera, a box will become around your face and your name will be written above that box. Okay, suppose if I show you this, uh, okay, just see this. Suppose like we are having a face like this, and like what will happen is, like when I open my webcam, suppose this is my webcam. Okay, this whole screen is my webcam, and this is my face. Like I'm having neck also, and like some, okay, like rest of the body and a face. So basically what our algorithm will do is, like when we open our camera, then a colored box will be come around our face, which will be like this, which will cover only our face part. Okay, like, okay, so a squared box will be formed around our face and our name will become here at the top. Okay, so our algorithm will do that. So like this is our webcam and this is me or anything or you, and a particular green color box will be come around this, and this is due to this Haar Cascade classifier, which is like defining our face basically, and our name will be written over that. So let me just show you that code. So basically like we are just doing the same thing again, which we have seen earlier also. Like we will start a loop, an infinite loop, which will be recording our camera. So we will start our camera by cap.read, and this ret and frame will basically be having our camera variables, like webcam variables. Return is basically like telling us that whether the camera is on or off. Okay, and frame is basically our main camera frame which we will be using. Okay, so first, like we have just converted our image to a grayscale image. Okay, like whatever the video we are having, we have just converted that into a grayscale video, and after that, like we are done same thing, like we have just detect multiscale, and these are the scaling factor and the number of neighbors. Like we have seen all this part in earlier video also. Okay, just get over the here. So this faces will basically contain our coordinates of the faces, like x, y, w and h. So basically if I change the plane, so this corner, like top left corner, will contain the, will having the point number x and y. Sorry, I don't have the mouse, so I'm typing like this. So x and y are the coordinates, and this is our width, and this is our height basically. Okay, so basically our this function will give us the x, y, width and height. So that all will be stored in the face array. Okay, and now like we are just starting a loop. Okay, so like in the new loop we are having a face, and with a face we are having the coordinates, and these coordinates are got from this face. Okay, so this face is basically the one face on which we are iterating, and everything this is same, just we are just cutting the part of the camera frame and just converting that to 100 cross 100 frame size. And now just see this, out is equal to knin. We are calling our function, just see, just concentrate here, we are calling our function knin, and now like train set and face section flatten. So face section dot flatten. So basically training set is our training set which we are carrying over from the past time, and face section dot flatten means, like we had defined this earlier also, like we are having a face section, just see here, we are having a face section, basically the camera frame which is just calibrating our face. So we are just flattening that to convert that into an array, okay, of one column and multiple rows. We are just flattening that because in knin our parameter should be a flattened array, only a array of one column. Okay, so our train set, we have that, we have our new face, just we are just passing the two parameters, and this will give us the output. Output will be that face, like training set we have trained, and face section is the section we got here. So it will basically guess the output that which frame we are having currently. So train set we got from data, face data. okay, all the face data we have. So it will just iterate over every data and just apply our KNN algorithm on that, okay, which is having a training set and a test set. Okay, on the basis of that, it will give us the prediction, which is this, and it will tell us that which point it belongs to. Okay, so like if we have this, um, basically like this is the stuff. Like if we are having a face in between, so it will just tell us that which face does our face belong to from this rest of the five faces, basically. Okay, and now like we have done that, like we got the output face from here, and now we have to make a box around the face and a text on the face, basically. Okay, so cv2 dot rectangle is a function which is used to make a shape by OpenCV. So what we are doing is just we are passing a frame, the coordinates, the top left coordinates and the bottom right coordinates. Okay, top left are xy and bottom right are x plus w y plus h. We are passing the coordinates, okay, and it will make a face around it. It will make a rectangle in these coordinates, and this is the color, and this is the width of the box. Color is 255, 255, 255. This is basically BGR color. Okay, blue, green, red. Okay, like if I do 0 here and if I do 0 here, so BGR means B, G and R. So if my B and G are 0 and my R is 255, it will make a box of red color. Okay, and if I make this like if I make this 255 here, so it will make a green color box. Okay, this is just a color format. And now like to put a text like here, like we write a function cv2.put text and it will just put a text here, and this is the font of the text, and this is the coordinates where I have to put my text, and this is my color of the text like BGR format. B is 255, so my text will be of blue color. Okay, and this is the width. Okay, and similarly like that we are just putting everything, and now like we are just displaying our face. Okay, like we are just showing our camera feed and all of that. Okay, and after that everything just we make a function. Like if I press a key Q, so my function will be end there and I can close my webcam, and my webcam will not be closed by anything except pressing Q. Okay, and now like after all everything we will just destroy the window and close the program. That's all. Okay, like this is a project of face cognition, and I hope that this is a very beginner level project in machine learning. Okay, so like I hope that this will be clear to all of you, and just write the just give the comment below that how how much you like this playlist of this project. Okay, and okay, so let's end this video now. Okay, bye.